February 1930. Clyde Tombaugh, 24 years old and fresh off a farm in Kansas, patiently scans photographic plates at the Lowell Observatory. He finds a tiny speck that turns out to be a new planet called Pluto. But in the 75 years since then, our close-up views of Pluto and its giant moon Charon still only come from the artist's imagination. Every other planet has been visited by NASA spacecraft, and the post office has issued stamps to commemorate their close encounters.
Of course, for Pluto, because there have been no mission to Pluto, the U.S. stamp says not yet explored. We aim to see a new stamp issued.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
January 19th, 2006. NASA's New Horizons mission to Pluto successfully lifts off from Cape Canaveral, traveling faster than any previous spacecraft. In just 9 hours, New Horizons passes the orbit of the Moon and begins a 9-year voyage to Pluto. February 28, 2007. The spacecraft zooms past the giant planet Jupiter, getting a 9,000-mile-per-hour gravity assist and cutting 2 years off its journey.
The spacecraft is outward bound from Jupiter, and we're on our way to Pluto.
All right.
The Jupiter flyby was a dress rehearsal for Pluto.
We got the night showing.
Oh wow, look at that.
Oh yeah.
New Horizons science instruments return detailed images of Jupiter's clouds, moons, and rings. If all continues well, things look good for July 2015 and the Pluto flyby. In the past decade, humans have been making amazing discoveries in the outer solar system.
The very first thing I did is grab my telephone and called up my wife, and I said, I found the 10th planet.
But astronomers continue to debate the definition of a planet and how the new discoveries change our evolving picture of the solar system. So now, the New Horizons mission is perfectly poised to shed light on this question and revolutionize understanding of our cosmic neighborhood. It's the ultimate in discovery and exploration.
We have no idea what the surface of Pluto looks like. So we could see craters, we could see geysers, we could see patches of frost. This is purely speculation. We have no idea what we're really going to see.
Late 2005, the long journey begins. Cape Canaveral, Florida, NASA's Kennedy Space Center. In the Kennedy clean room, the New Horizons spacecraft takes its first short flights. It's just over 2 meters, about 7 feet from the tip of its high-gain antenna to where it joins the rocket, about the size of a grand piano. Fully loaded with fuel, it weighs 1,000 pounds. Not very large or heavy for a planned journey of almost 20 years.
The main difficulty about going to Pluto is that it's so far away. The Earth is almost 100 million miles away from the Sun. Pluto is 30 times that far, 3 billion miles away. To get to Pluto in our lifetimes means it has to go very fast. Its average speed is more than 10 miles per second. And to do that, it had to be light.
One of the unique things about New Horizons is that we built a very light spacecraft and bought a very large launch vehicle. And the combination is ferocious. It gives us a very high flyout speed because we have a very long way to go.
Sprinting away from Earth on launch day, New Horizons crossed the orbit of the Moon in just 9 hours. Apollo took 3 days. The spacecraft reached Jupiter in 13 months. Galileo took 6 years. But even traveling more than 50,000 miles per hour, it will still be 2015 before New Horizons reaches Pluto and Charon.
So it's not that we're dawdling, we have a long way to go.
Why send a spacecraft on such a long and difficult journey into such a challenging environment? For the science team, it's a voyage back in time to see, close up, evidence of how solar systems form from clouds of gas and dust, and how Earth and all the planets were born.
We're going to learn about how planets are built. Because what Pluto is a planetary embryo, an object that's partially formed as a large planet, a stage in planetary formation that the Earth went through, that Mars went through, that all the larger planets had to pass through this size scale. But here we see an object that didn't get any further in the case of Pluto.
The National Academy of Sciences rated this mission to Pluto and beyond the most important planetary mission of the decade. That's because New Horizons could rewrite everything we know about the planets of our solar system.
And if you think about the solar system, the so-called terrestrial planets, they're rocky objects in the inner solar system, Mercury, Venus, Earth, and Mars, have a lot of similarities. Then you step out a little bit further and you get into what are called the gas giant planets. These are huge objects which are dominated by large amounts of molecular hydrogen and helium gas. And that's Jupiter, Saturn, Uranus, and Neptune.
And that was it. We sort of stopped there. And then there was the little misfit Pluto at the outer edge of the solar system. Poor little Pluto, all on its own.
Then in the 1990s came a series of discoveries that changed everything. Researchers found more and more icy objects in a massive region of the outer solar system known as the Kuiper Belt.
And once we discovered the Kuiper Belt, everything sort of fell into place. The understanding that, in fact, Pluto and Charon are members of this other class of objects called the ice dwarfs.
And in fact, we think that these ice dwarfs are the most populous class of planetary body in our entire solar system.
That tells us, from that respect, Pluto's not special. It's got lots of company out there.
Ice dwarfs aren't just far out there. In the early days, 4 billion years ago, they may have had a role in shaping Earth and bringing our planet the materials of which we're made.
The collisions within the Kuiper Belt produce the short period comets, which then fall in towards the sun and bombard the Earth, sometimes bringing some of that raw material from which life formed and some of the water that's on the surface of the Earth.
This information about the Earth's birth isn't available anywhere else.
So the key part of that big puzzle of how the solar system formed will come from looking at Pluto, understanding its nature, what it will imply about its formation, how it came to be, and everything about it.
Coming up, with New Horizons safely on its way to Pluto, find out what sophisticated scientific instruments are on board to unravel Pluto's mysteries. For this first ever trip to Pluto, the science team wants to find out the basics. What do Pluto and Charon look like? What are they made of? And what kind of atmosphere exists? Their hunch is that all these questions are connected.
With Pluto, if you want to understand the atmosphere, you have to understand the surface. If you want to understand the surface composition, you have to understand the geology. If you want to understand the geology, you've got to understand the atmosphere. It's all tied together, and so we have instruments to study every aspect of Pluto.
The 7 science instruments on board New Horizons are ingeniously designed. They're small and weigh very little. On average, each uses no more power than a household nightlight, and they're intended to work together seamlessly.
We picked names for most of our instruments. We have Rex and Alice and Ralph, and it's just a happy family.
The black and white telephoto camera called Lori will be used for navigation in the months before closest approach and to study Pluto's surface.
This big barrel is a telescope called LORI, the Long Range Reconnaissance Imager. It's our biggest, most powerful camera in terms of resolution power.
The cameras are key. For over 60 years, Pluto remained little more than a dot, as small and dim as a walnut seen from 30 miles away. In the 1990s, even the Hubble Space Telescope showed just a blurry surface. And this true color image is the best we can do with Hubble and advanced computers. Pluto clearly has a varied surface, but whether these are mountains or craters or polar caps remains a mystery. That's where New Horizons wide-angle camera comes in.
We want to get up close and personal.
Ralph is our main color camera. It's also the camera that's going to take our main global maps of Pluto.
We can get in and map at scales of kilometers and sub-kilometers and even down to tens of meters.
Football field-sized resolution at Pluto. We're going to be able to, to see things thousands of times more precisely than what we've been able to do with the Hubble Space Telescope.
Strangely enough, Pluto's surface seems to have about the same brightness as freshly fallen snow on Earth. It appears so dim only because it's so small and very far away. Equally bizarre, Pluto sometimes behaves more like a comet than a planet. When its eccentric orbit brings it closer to the Sun, the surface heats up and produces a denser atmosphere. Ralph's sister instrument, using a different part of the electromagnetic spectrum, will be studying that.
This is the ALICE ultraviolet spectrometer, which will probe the composition of Pluto's atmosphere and also study its surface.
It measures light with a shorter wavelength than what you and I see. We fly past Pluto, that's the antenna direction. We're going to turn, so the antenna is pointed back at Pluto, back toward the Sun. And we're going to watch as the Sun passes behind Pluto, and we're going to see the sunlight get absorbed at these ultraviolet wavelengths, and we can tell what the atmosphere is made out of at these different heights.
As Pluto approaches and retreats from the Sun, it's thought that there are seasons and weather that resurfaces the planet with fresh, bright ices. Some researchers think this is what creates the light and dark regions, but as yet, no one knows. New Horizons hopes to get to Pluto before winter sets in, and the atmosphere freezes back down to the surface as solid ice. Along its 9-year voyage, New Horizons will also be collecting some very important samples of dust.
What's the big deal about dust? We have dust everywhere. Dust in your house, dust outside, dust all out the solar system. Well, dust comes from the grinding up of material that gets shed and left around. In the case of the solar system, we believe that the dust that's flying around the solar system was produced by the grinding up of asteroids, the grinding up of Kuiper Belt objects, the grinding up of ring particles and so on, that is left over from the process of not just forming the solar system, but its constant evolution over time.
So the last of the 7 instruments is a special dust counter. But this instrument comes from a very surprising source. Every part, from logo to detectors, was designed entirely by college students.
Its job is to profile the density of dust particles all the way across the solar system for the first time. But the real breakthrough of this instrument, it's the first time that students have been able to build a flight quality instrument on their own and fly it on a mission to a planet.
The students documented their project in behind-the-scenes home videos.
Our final instrument will have 12 of these dust detectors all lined up on a panel about 0.1 meters squared.
Till now, no dust counter has gotten data farther out than 18 times the distance of Earth from the Sun. Design specs from the SDC are twice that and more, lasting decades, traveling billions of miles, surviving temperatures near absolute zero. Even though it's a student project, the dust counter is every bit as robust and serious as the other instruments on board. The students faced review boards of veteran scientists and engineers as part of the design process. Together, the 7 science instruments are the most powerful set of detectors ever sent on a first flyby of any world in our solar system. But making sure the Pluto flyby is successful meant a race against time to launch in 2006. And before they could ship the spacecraft to the Cape, the hardware and the science instruments all have to go through a rigorous test program. For this mission, keeping on schedule was critical.
It's also important that we get there as soon as possible because Pluto does have an atmosphere right now, but it's moving farther and farther away from the Sun. And at some point, that atmosphere is going to freeze out.
Although meeting the target launch date is critical, so is making sure that all the hardware works together like a finely tuned machine.
One build of a spacecraft, you build the individual boxes and instruments first, And they go through their own tests, both functionally and then environmental tests. And that's sort of equivalent to the members of an orchestra, each tuning up. But once you build it as a spacecraft, once you've assembled it, then you're playing the symphony. And that's what we've been doing. We've been testing it as a system.
And then we test it again, and then we test it about 5 more times. Once we launch this, we can't go after it with a screwdriver. We can't go fix anything that isn't working. And the test program, the full-up test program, is more than a year long. A big part of the testing that gives us confidence that it's going to work in flight is the environmental testing. So we put it into an environment that's pretty much exactly like it's going to see on its way to Pluto and at Pluto. That includes a thermal vacuum tank where we put it in this big tank, we pump all the air out, it's in a vacuum just in space, then we heat it up and we cool it down, just as it's going to see when it's actually in flight.
And it's not just the extreme cold that engineers test for. The launch itself puts huge stresses on the spacecraft.
These rockets, they're gigantic. They shake a lot. If you've ever seen a paint shaker at a hardware store where it mixes the colors into the paint, that's exactly what the spacecraft is going to go through during launch. One of the things we do is we put the whole spacecraft on a gigantic vibration table, a paint shaker, and shake it. And then test it after that, and shake it again and test it again.
Test phases at APL and Goddard have been very intense. We're running a 7-day-a-week, 3-shift-per-day operation.
Nothing was easy. Even getting to Andrews Air Force Base meant fighting traffic. Leaving home for Cape Canaveral and the final critical months before launch, the engineers in charge were a little nervous.
This is definitely high on the stress level curve. Getting the spacecraft moved from Columbia, Maryland, all the way down to the Cape is pretty tough.
Like packing for a long trip, everything you need must come along. Test equipment, spares, tools.
Everything we're doing is the last time we do it. We want to make sure every bolt is exactly tight and fastened correctly. Everything's been assembled, tested. The records are kept properly because there's no going back. This is a flight build.
Saturday, December 17th, 2005. Spacecraft and third stage, in its closed-up fairing, like a giant fragile egg, are placed on top of a huge transporter. With 9 axles and 81 wheels, it's able to raise and lower itself to roll over bumps and up and down slopes without tilting the cargo. Working round the clock, they arrive at Pad 41 before dawn. 75 years after the discovery of Pluto, 17 years after a mission was first proposed, the dream of exploring the 9th planet was now only weeks from launch.
For most people on the project, in a sense, this is the end because it will be built and launched and on its way. But for the science team and the operations team, this is the beginning. This is where we begin the journey. Like a ship, we launch it.
On January 19, 2006, after nearly 2 decades of planning, building, and testing, a picture-perfect launch thrilled the mission operations team back at Johns Hopkins. But the long journey to understand Pluto actually began 75 years earlier, far away in the American West. The story of Pluto's discovery begins here, Flagstaff, Arizona, the Lowell Observatory. Named for its founder, Percival Lowell, a rich Bostonian who was fascinated first by the possibility of water and life on Mars, and then by the search for Planet X, an undiscovered world out beyond Neptune. Pluto was discovered here, and the observatory remains a center of Pluto research today. Astronomer Mark Bowie personifies the ingenuity and persistence it takes to study Pluto.
Part of why I like Pluto so much, because it's a cold, icy place.
Bowie's role on New Horizons is to help find targets far out in the Kuiper Belt, where the spacecraft will travel after it has flown by Pluto and Charon. This homegrown instrument, named Mimir after a Norse god of wisdom, will be placed on ground-based telescopes to study ices on Pluto's surface before the spacecraft gets there. For 2 decades, Bowie and colleagues have used the best instruments available to map the planet. In the mid-90s, he and Alan Stern collaborated in using the Hubble Space Telescope to make the first direct images of Pluto's surface.
Hubble has revealed the first glimpse of Pluto for the first time, and it's exciting to Mark and I and to our whole scientific team to be able to see this object that no humans really could glimpse as a real planet, as a real object in the solar system previously.
In 2002, astronauts placed the new Advanced Camera for Surveys on board Hubble, and Bowie now had data for a new map.
I think this map is probably the best map we're going to get prior to the spacecraft getting there.
Pluto clearly has dramatically varied geology, though the images are still mysterious. But what a transformation from the dot of light that was Clyde Tombaugh's first sight of Pluto 3/4 of a century earlier. 75 years to the exact day and time, Observatory Director Robert Millis shows us how the discovery was made.
75 years ago, Clyde Tombaugh sat at this machine and became the first person to ever see the planet Pluto.
The machine is called a blink comparator. Tombaugh used it to look at photographs of the same patch of sky taken a few days apart. Night after night, he'd patiently expose the large glass plates. Day after day, he'd blink the plates back and forth, looking for anything different from the fixed points of starlight. Decades later, Tombaugh still recalled just how uncomfortable and challenging the search for Planet X turned out to be.
You get cold, you get numb. There's a lot of perseverance, because this gets brutally monotonous.
Blinking back and forward, Tombaugh was looking for anything that shifted position.
The only means you have identifying a planet is going to be small. It's like a small star image. The only clue you have is it shifts position with an interval of a few days in a night's time. That's the only clue you have. So you've got to see all these star images, hundreds of thousands of them, to see if any of them shift position during the interval between the first and second plate.
That small movement was just what Tombaugh saw on February 17, 1930. The arrows were added to show its position a few days apart. It was just what Lowell and Tombaugh wanted to see, a distant planet. After some debate, an English schoolgirl, 11-year-old Venetia Burney, came up with the name Pluto, god of the underworld. PL, of course, were also Lowell's initials. By studying the motion of that dim and distant dot of light, astronomers discovered a Pluto year, the time it takes to move once around the Sun, was equal to 248 Earth years. The angle of its orbit, seen here in silver, was steeper than any other planet. Its distance from the Sun also varied more than any other planet. For 48 years, that was all anyone knew about Pluto. Then, in 1978, astronomers Jim Christie and Bob Harrington analyzed new plates taken at the U.S. Naval Observatory in Flagstaff. Christie noted an elongation of the planet to the north. 1 month later, the bump had disappeared. Blink the images back and forward just like Clyde had done, and you see the bump is moving. Their conclusion? Pluto, like Earth, has a moon. Christie suggested the name Charon after the ferryman of Pluto's underworld in Greek mythology, but preferred to pronounce it Charon, more like his wife's name, Charlene. From the motions of Pluto and Charon, astronomers could work out that the moon was almost half the size of its planet, so large that both objects spin around a central point, their mutual center of gravity, outside Pluto. Pluto and Charon were the first binary planet known in our solar system. Using the basic physics of their orbits and their distance from each other, astronomers were able to calculate their mass and size. Pluto was smaller than our moon, about 1,500 miles in diameter, and had only 1/10 of its mass. Pluto and Charon together would barely stretch across the continental United States. From its size and orbit, astronomers estimated that Pluto is perhaps half rock and half ice. That makes it one of the largest of a whole new class of objects, the ice dwarfs, living out in what's known as the Kuiper Belt. This region is named for Gerhard Kuiper, a leading mid-20th century planetary astronomer. Kuiper suggested that the solar system didn't end with Neptune and Pluto, but that there should be a disk or belt of other worlds somewhere way out there. In 1992, from a mountaintop in Hawaii, David Jewett and Jane Liu found the first Kuiper Belt object. They were using new and highly sensitive CCDs, like the sensors in a modern digital camera. But their technique was essentially an updated version of Tombaugh's work. Take carefully registered images of a patch of sky and see if anything moves against the distant stars. This one, QB1, did just that. Jewett and Liu had found the first Kuiper Belt object. It was just a few hundred kilometers across, about the size of an asteroid. In 2002, Caltech astronomer Mike Brown and colleagues found a Kuiper Belt object half the size of Pluto. In 2004, Sedna, another world, 3/4 the size of Pluto. Brown kept on looking, using computers to do the work of Tombaugh's blink comparator.
We do exactly the same thing. Clyde Tombaugh is the one who basically figured out the system for finding these things, but we do it all by computer instead. These are 3 images in a row that are blinking on the screen, just like Clyde Tombaugh would blink. On the morning of January 5th, 2005, I was looking at these very images, and I clicked the button saying this one's no good, and I suddenly see this object here very clearly moving across the frame in dead center. This is the one where I almost literally fell out of my chair, because it's perhaps it's close to being the brightest object we'd ever seen out there, and it's also moving extremely slowly. Slow means it's far away. Slow and bright means it's really big. If you combined more distant with anything we'd ever found and almost the brightest thing we'd ever found, you knew immediately that this thing had to be the biggest thing we'd ever found in the outer solar system. The very first thing I did is grab my telephone and called up my wife, and I said, I found the 10th planet.
2003 UB313, the random name assigned by Brown's computer, was 25% larger than Pluto. Until an official name was chosen, Brown came up with a temporary nickname, commemorating Percival Lowell's search for Planet X.
We had actually been reserving the name Xena for the first object that we found larger than Pluto. We wanted something that started with an X for Planet X. We wanted something that was mythological. Now Xena is only TV mythology, not real mythology, but we figured Pluto is named after a cartoon dog, so that's okay. And we wanted something that, we decided there weren't enough female planets, so we were going to name another one female planet. So if you take those 3 together, you get Xena.
Xena has now officially been named Eris, goddess of discord, which seems appropriate. Some astronomers argue that Pluto and Eris, as Kuiper Belt objects, should not be classified as true planets. Others disagree. In August 2006, in a controversial decision, the International Astronomical Union reclassified Pluto, Charon, and Eris as dwarf planets. But Mike Brown thinks the new findings far out in the Kuiper Belt only make the New Horizons mission more exciting.
Pluto is the closest member of this new class of objects we're finding. The next best thing to studying all of these objects out there is to go look at some of the big ones. Go look at Pluto. It's not the biggest one out there, but it's the closest really big one that we can learn a lot about. So I think that going to Pluto is much more exciting today than it was even a year ago.
In 2005, Hal Weaver and Alan Stern used the Hubble for another close-up look at Pluto and Charon.
We want to know everything that could possibly be along our path as we're going through the Pluto-Charon system.
The result was an historic and astonishing discovery.
This was just incredible. In fact, it was so incredible we almost didn't believe it at first.
They saw 2 small, dim moons where only Charon had been known before. It would double the excitement of the close encounter.
We get 4 for the price of 2. You know, instead of having just Pluto and Charon, we now have another couple of exciting moons to investigate. Pluto is an even more interesting place than we imagined.
Mark Bowie went back and confirmed the discovery by reanalyzing previous images. He made this true color portrait of Pluto and Charon with the newest moons, Nix and Hydra. New Horizons will speed through the Pluto system in less than a day. To maximize success, the mission would use flying by Jupiter, the largest planet in our solar system, as a dress rehearsal for encountering the smallest. Early 2007, engineers and scientists got ready. Unlike missions that go into orbit around their target planet, New Horizons is traveling so fast there's no practical way to slow down. After a 9-year trip, closest approach to Pluto and Charon will flash by in less than a day.
This is going to be incredibly nerve-wracking. As we do the encounter, we get one shot at flying by Pluto. That's both terrifying, also very exhilarating.
Pluto is so far away that radio signals from Earth take 4.5 hours to get there, and 4.5 hours back. This 9-hour round-trip light time means computer commands for every aspect of the encounter, from navigation to operation of the science instruments, must be programmed, tested, and uploaded ahead of time.
It's very scary to build a spacecraft and then launch it and not get any data for 9 years. And so it's really key to test out the instruments before we get there.
June 2005, 10 full years before arrival at Pluto. The mission operations team runs a detailed simulation of the encounter, modeled to the split second. To test the spacecraft still more rigorously, the project decides to use the Jupiter flyby to take actual scientific observations. They'd look at the volcanic moon Io. They'd study Jupiter's cloudy surface and aurora.
This will be a wonderful dress rehearsal for the whole process of putting together a complicated sequence. And we only get to do it once at Pluto, so having this practice at Jupiter will be very valuable for that.
January 2007, still another simulation. The Jupiter encounter has mission planners working harder than ever.
So it's more intense than by several orders of magnitude than anything we've done as far as memory usage, which translates to number of commands.
It's more intense actually than our Pluto simulations we did pre-launch.
I guess the usual stuff. Axis normal, our SPE is going to range from 7.056 degrees.
The observation starts 10:06:16.
Before any command is sent up to the spacecraft, it's reviewed by a representative of every subsystem, power, thermal, data handling, as well as the science team. One bad line of code can cripple a spacecraft. The Jupiter encounter has 40,000 of them. Every command is run through a series of computers, identical to those up in space, except that this New Horizons mission simulator is safely on the ground in Maryland. February 28, 2007, 45 minutes after midnight GMT. New Horizons closes in on Jupiter. Hours later, scientists and engineers gather at the Applied Physics Laboratory for what they hope will be the first post-encounter transmission from the spacecraft. Mission managers coordinate with researchers across America. Experienced operators stand by at stations dedicated to each instrument and subsystem. The ACE, or Lead Flight Controller, communicates with NASA's Deep Space Network Station in Australia. Alice Bowman is Mission Operations Manager, or MOM. Her professional family includes some of the brightest engineers around.
Today's very important. It's our Jupiter flyby day. And of course, the test is coming right up. We'll see if a spacecraft made it through the dangerous radiation at Jupiter.
For this milestone in the life of the mission, all hands are on deck.
It's real big. As you can see, we have a lot of people coming in today, a lot of scientists who wanted this information off the satellite that we've been trying to get for them. So today is real eventful.
I would put it somewhere between launch and actually getting to Pluto. I'd say it's the third most critical activity in the whole timeline.
We're really putting the spacecraft through a stress test. That's our primary objective. But as long as we had to stress it, we thought we'd stress it with 700 science observations.
700 observations. 40,000 commands. Science planners work with guidance and control engineers to write a playbook for the encounter, a script for every time tick of the flyby. At Jupiter, New Horizons is on her own. Here on Earth, they wait.
You guys nervous?
No, not really.
Nothing we can do at this point.
That's right, not nervous.
Nah.
Not a bit.
This is all done by remote control. That's the nature of this business. 500 million miles away, our little puppy is doing its job and doing very well.
Just come up on track like it always does. So.
We're about a little less than 6 minutes away from our first look at telemetry.
They'll know all is well when screens light up with green text indicating the spacecraft has survived. DSN Australia confirms that New Horizons has phoned home.
Pluto Ace.
Go ahead, Pluto Ace.
Yes, we're now receiving telemetry and we're locked.
RF mom on Pluto 1. Status check.
RF is green.
PI, this is mom on Pluto 1. Spacecraft telemetry for all subsystems is nominal. Spacecraft is outward bound from Jupiter, and we're on our way to Pluto.
Congratulations. All right.
Oh, relieved.
Go ahead,
we expected everything to go well, but it's good to know that it really did. Now we still have to wait for the data to come down, see what's happening with the radiation levels on our instruments, and waiting for that really good picture of Io that we should be getting in a couple of hours.
Good, everything's looking really good at this point. The station's cooperating, no problems with the station, the spacecraft's in a good state, all's well.
Jupiter's not our ultimate destination. It's very nice, that we can actually get a lot of great scientific data for free, basically. We get that gravity boost, the most important thing, but after that, just getting that extra science and the extra practice for doing an encounter, which are really hairy. These encounter situations where it's all or nothing. You fly by and you don't return. We have to make sure everything works perfectly, so we're going to learn some lessons from this experience, apply them to the Pluto encounter, and hopefully make for, an even better Pluto encounter.
The engineers could tell right away that all spacecraft systems were nominal. But the scientists wanted to see the very first pictures of Io. They'd gotten used to fancy computer graphics depicting an imaginary trajectory and volcanic plumes. But the actual images just in from Jupiter would determine scientific success or failure.
Yeah, this is the highest resolution image of Io with its spectacular plume, we hope.
Like Clyde Tombaugh decades earlier, they hoped for discoveries.
Flight radar. Oops.
The spacecraft took the images hours before, but for the researchers, this was exploration live and real time.
There it is, off the, wow. Okay.
Camera and spacecraft delivered as promised.
2 plumes off the limb.
Okay.
Got both.
We got the night showing.
Oh wow! Look at that.
Oh yeah.
And we got both of them. We got both of them.
And another plume.
my gosh.
Rising into sunlight.
That's right, yeah.
The first raw images might be fuzzy, but now they knew their aim was true. Computers would be able to clean them up and begin to update the textbooks.
Yeah.
Hal and John rushed next door to let the full science team see how their spacecraft was performing.
Second plume has a different shape.
Researchers called out requests to adjust brightness and contrast to reveal details hidden in the pictures. Now they knew for sure they'd captured the volcano called Tvashtar, spewing its sulfur plume 180 miles up into space.
How about that one up there?
What is that?
How about this one here? Is that a mountain or is that a mountain?
Many of the scientists were veterans of previous missions, but precise navigation and state-of-the-art cameras were revealing the Jupiter system as never before.
There was the one Voyager 1 image, the high-resolution image that showed the filamentary structure, but nothing like this.
Yeah, that's
Professional astronomers, of course, thrill at each new image, but the general public also had a role in targeting New Horizons cameras.
And what we actually did is went out to some blog sites where talented amateur astronomers and planetary scientists discussed the latest findings.
Like the student dust counter, this was the first time the public had a chance to shape a deep space mission.
We asked them, suggest to us some of your best ideas for what we call Kodak moments, unique geometries when we could obtain something evocative.
Out of this process came the idea for snapping Io and Europa lit edge-on by the sun. Stern's favorite captured Europa rising over Jupiter.
It gives you that feeling that you're actually at Jupiter, and you have a view that you might not expect to have from a spacecraft, as if you were actually there, an astronaut making the flyby with New Horizons.
There were 7 Kodak moments, but New Horizons returned almost 700 observations.
And we have very detailed images that show us much finer structure now in Jupiter's ring system than had ever been obtained by any previous mission.
The cameras had been designed to work in the much dimmer light far out at Pluto, but special software helped record the structure and dynamics of Jupiter's clouds, including both the great and little red spots.
No spacecraft had made detailed observations since the formation of the little red spot. And this is not such a little spot, after all. It's as large as the Earth, practically. And we happen to be the first mission to Jupiter since the coagulation of some smaller storms into the so-called little red spot.
So the spacecraft passed this intentionally extreme stress test with flying colors.
Because I would have been very happy if half or more of the observations had worked out, rather than upwards of 95, 97%.
Leaving Jupiter, New Horizons will fly down the planet's giant magnetic tail, another first for this mission. Then it will be time for an 8-year cruise to Pluto, with long periods spent in hibernation, instruments turned off.
Well, Cruise for New Horizons is a 8-year sequence during which most of the time the spacecraft is in hibernation. And we do that in part to save money, but more importantly to save time, wear and tear on the electronics. In fact, most of the electronics boxes on New Horizons, although they will be 9.5 years old on reaching Pluto, they will only have between 2 and 3 years of on time. So for practical purposes, the spacecraft is not 9.5 years old, but 2.5 or 3 years old.
Commands out.
Keeping the spacecraft young is one thing. Mission planners also had to think about who would be around to operate the spacecraft in 2015. Many of the faces you see around New Horizons are relatively young. That's also no accident.
You know, if it's on like that, let's say yeah.
The project wants to make sure key team members are still on the job when the spacecraft gets to Pluto.
Yeah.
How old are you going to be?
In 2015?
Yeah.
I don't know, somewhere in my 40s.
Oh, and you're a youngster.
Yes.
If all goes well, even 2015 won't be an end date for New Horizons. It should have enough fuel to travel onwards, to rendezvous with 1 or 2 ice dwarfs beyond Pluto.
3, 2, 1.
The story of New Horizons may be a tale of high-powered rockets and sophisticated science instruments, but it's also evidence of human persistence, passion, and boundless imagination.
It's going to be an almost timeless object, that we're building something that will not only outlast the pyramids, but outlast the mountain ranges of the Earth. This will fly through the galaxy essentially unchanged from the way we build it, and it will be just that way for billions of years, literally. That's a stunning thing to me every time I think about it.
New Horizons is not just breakthrough science. It's another milestone in America's vision of space exploration.
Humans are explorers. I mean, we're not satisfied just to sit still with the status quo. We want to understand our place in the universe. We want to understand why we're here. Is the Earth unique? Is life unique? And science, and in particular space science, where we're going out to study the planets, is a very important component of that process.
Virtually every place we've sent a spacecraft on a first reconnaissance mission like this that we find out that our Earth-based notions were flat wrong. So I'll tell you what we expect, but before anything, what we expect is to be surprised.